Okay, greetings everyone. So we've already seen that the concept of stack. Now we want to see how we can implement stacks using arrays. Okay, so let's assume that we have a list of numbers and we want to implement a stack, and we want to store these numbers, these list of numbers, these collection of numbers in a stack. And we want to implement our stack using arrays. Okay, so in this part, in this example, I'm just going to assume that we have a non-dynamic or a static array. Means that the size is constant. Okay, so first of all, we have a variable that we can store the size of our array, whatever it is. Right, we want to make sure that our array is big enough that can store all the values that we want to store in it. So this size is usually chosen as a big number, let's say like 100 for example. Of course, we have the option to use a dynamic array and rechange the size, increase the size and change the size or increase the size. But I'm just like gonna focus on the static array in this case. So what we want to do, we want to place these numbers in the stack. And so one advantage of having arrays is that we can use the index of the arrays. So like each element of the array has an index. Okay, so if we have an empty array, so then it means that like we haven't put anything in the array yet, we haven't pushed anything in the array yet. So we can have a variable, let's call it top, that this variable, it would represent the index at which the top of our array is right now. And the top of array is going to move as we insert numbers. So the last number that we insert is going to be at the top of the array. So initially, when our stack is empty, we choose the value -1 to be the value of our top. Why do we choose -1? Because this number means that what's going to be the next index that when we want to push an element into our array, it's going to be like that element, that data item is going to be stored at what index, right? So when you have an empty array, the first number that you want to insert, it's going to be inserted at A0. So the top of array becomes A0. So this number, it's always like one smaller than what's going to be pushed, what's going to be the index of the number that's going to be pushed next. Okay, so this is like how we initialize our our variables. And we have an array of, like, if this is a constant number, I can just like say we have an array of this size. So integer array, this is integer, this is integer, this is constant integer. Okay, so these are the variables that we have. Now let's see what happens when we want to push an element into the stack. So when we want to push, the first thing we want to do, we want to increment our top value. Okay, so we want to increment the top value because, as I said, this would represent the top of the array at this point. Right now, because our array is empty, then it means that we don't have any element. That's why like top is -1, right? But the first number we want to push, so we're gonna increment top, and then so top becomes 0, and then we want to say a top is equal to the data that we want to push, to the number that we want to push. So in this case, this is 10, so 10 goes here. So this is how we push, okay? Then if we want to push another one, so if we call the push function one more time, so top becomes 1, and we want to place this number at a, so this like, then in this case, let me see if you can see the whole whiteboard. Yeah, so at this point, this is the top of the array, or this is the top of the stack. And next time, like when you call the push, now the top is gonna move to a 1, right? So this is gonna be 20, so that means that we have placed 20 here, and so on. Like if you push, if you call the push function again and again and again, so like you can have 30, 40, 50, and so on. Okay, so this is one thing that we can like implement the push using the top variable, and this is gonna or like the top of the stack, it's gonna move as we call the push function. It's gonna move from left to the right. One thing that we have to make sure that, so we always check when we push, if our top is already equal to s-1, right? If top is already equal to s-1, it means that our array is what? Is already full, right? So we have to check if top is less than s-1. If top becomes equal s-1, it means that we have, if top is already here, it means that we have exhausted our array, right? So you can't push any more new items here. So this is something that we have to make sure we consider before we push. Now, the other operation that we want to implement is the pop function, right? So if we want to implement the pop function, so it means that we already know what the top index is, right? And we want to return it, but at the same time we want to move the top index 1 to the left. Okay, so what we want to do would be basically so if I want to like implement this using a C++ notation, I can do this as like this: a plus plus top is equal to whatever the argument is. If you want to do pop,